Good morning. Today we will go over the last section of Chapter A, which is about radical equations. Let's look at the first part first, fill in the blank. In solving radical equation, the first step is to isolate the term with a radical. So we'll put isolate right here. It's very similar to how we solve absolute value equations. We isolate the special part. Since we're solving radical equations, we solve the radical part. Number 2. A blank is an equation in which a variable appears in one or more radicals. This one is referring to the definition of a radical equation. So if you see a radical sign in the equation, chances are it's a radical equation. Most of the time you're going to see square root. Very rare time you will see cube root, but most of the time it's going to be square root. Number 3. The squaring property of equality states that if two numbers are equal, then their squares are also equal. This is basically how we will perform inverse operation on both sides to get rid of the square root part. We perform inverse operation of square root, which is square, and that's how you isolate the variable. Number 4. A possible solution of a radical equation that does not check is called an extraneous solution. So it's the solution that's not valid. Extraneous solution. That means when you solve radical equations, it's always recommended that you have to check your solution. When you check your solution, you simply plug in the potential solution that you found back into the original equation, check the left side and the right hand side, see if they are the same. Let's look at one example. Sorry about that, let me turn that off. Let's look at practice number 1. Solve and check. 7 minus radical 3y plus 1 equals 3. First thing I like to do is highlight the radical part. Our radical part is right here, radical 3y plus 1. So your goal is to isolate that part. There is a 7 that we need to get rid of. The inverse operation of 7, some people might find it difficult, so I'm going to give you a little trick. Notice that there is no sign in front of 7. What you're going to do is you're going to add a little plus in front of 7, and then you will be able to do inverse operation because we do have a sign that's attached to 7. So our inverse operation for the first step will be subtracting 7 from both sides. This is a little trick that will help you perform inverse operations to numbers that are just by itself. And also notice that the minus sign after 7, it has nothing to do with 7. That minus sign belongs to the radical part. It doesn't belong to 7. So if you do inverse operation, you will do inverse operation of plus 7. And that's why we subtract 7 from both sides. On the left hand side, we will get negative radical 3y plus 1. Do not forget that negative sign because it's part of the radical part. Equals, on the right hand side, 3 minus 7, that's negative 4. And then we are going to divide both sides by negative 1 because we have that invisible negative 1 outside of the radical part that we need to get rid of. So I divide both sides by negative 1. As a result, on the left hand side, we have radical 3y plus 1. On the right hand side, we have positive 4. Now we successfully isolated the radical part. We perform the inverse operation of square root, which is square. So you square both sides. As we learned from early chapters, early sections, the square root and the square, they cancel each other out. So we simply have 3y plus 1 on the left. 4 squared is 16. And now you can see we have a very simple linear equation, which should be very easy to solve. Subtract 1 from both sides. We obtain 3y equals 15. Divide both sides by 3. we got our potential solution, y equals 5. Notice that I say potential solution because we need to check whether or not this is a valid solution. So let's check whether or not it's correct. When you check your solution, first write down the original equation, just copy it. And then I'm going to write down my potential solution 5 right below the variable y. So 5 right here. And then you copy the rest of the equation. So you have the 7 minus radical. First part is 3y, which is 3 times 5. Make sure you put a little dot in between 3 and 5. And then plus 1. This is the left-hand side. We want to check if the left-hand side is the same as the right-hand side. So you put a little question mark above the equal sign. Let's follow the order of operation and evaluate each side. On the left-hand side, underneath the radical part, we have 3 times 5, that is 15. 15 plus 1, that is 16. Further simplify, radical 16 is 4. So you're checking is 7 minus 4 equal to 3, which is true. So you could conclude that our solution is correct. Y equals 5, and you could box your final solution for this one. Just make sure that you check your solution. It's part of the work that you need to show for solving radical equations. Moving on to practice number 2. An electrical appliance with resistance R draws current I and has power P. These quantities are related by the following formula: I equals square root of P over R. If an appliance has a resistance of 20 and draws 9, find its power. So we simply plug it in, right? We have resistance R, let's change the color, is 20, and we have the power is 9. The current is 9. And we want to find out the power. Let's write down the formula. I equals radical P over R. And we're going to plug it in the values that's given. I is 9. P is unknown, but R is 20. And I'm going to copy the rest of the formula. So you should get this, right? 9 equals radical P over 20. And then we're going to perform inverse operations on both sides. The radical part is already isolated, so we simply square both sides. On the left-hand side, 9 squared is 81. On the right-hand side, the square root and the square, they cancel out. We simply have P over 20. Now this is again very simple linear equation. We need to isolate variable P. To isolate variable P, we will multiply both sides by the denominator, which is 20. It's going to give us 1620 on the left-hand side and P on the right-hand side, because these two 20s, they cancel out. And we solved our problem to number 2. And that's pretty much 8.4. It's a very short session on solving radical equations. For your homework, I have another video which talks about all the odd numbers in your exercises, and it covers more complicated problems, like problems that have more than one radical part. In that case, what you're gonna do. Make sure you watch that if you encounter any problems like that. And that's pretty much it for chapter 8. And also that ends our entire semester. Next time when we meet, we will go over the practice final exam, and then we will address some of the questions that you guys might have. You can find practice final exam in our class notebook online. I highly recommend that you complete that first on your own before attending our online virtual session next time. And that's it for today. Thanks for watching.